Okay, so I'm back again. Right. The index number is 24254020209. The name goes by Stan Juma Blankson. Right. So we need to talk about the next question. We need to talk about the part or the tax 2. All right. And so the tax 2 here says that for the we use this diagram, the DFA diagram here, to answer the following questions. Produce a transition table for the DFA above. Minimize the DFA above, include the minimize DFA transition table, and produce the transition table for the minimize DFA from B. Right. Okay. Now let's talk about part A. The first question that says that we should produce a transition table for the DFA above. Okay. Now, how do you provide a transition table? The transition table goes like this. We need to first of all understand what the transition table is and how we should go about that. And since we all know that the accept state, or let's start from the beginning. The start state is where the arrow is pointing to. So in this diagram, as you can see here, the arrow is pointing to Q0 or Q0, and we call that as our start state. And also have to identify the accept state. The accept state is identified by a doubled circle, and so if it is doubled circle, that means it's what is accepted, and we call that as our accept state or the final state. And then in the transition diagram, in the transition table, what we do here is that we will use the same approach, what we are seeing in the diagram, to derive the transition table. And so we use the arrow which is pointing to Q0 to also point to the Q0 in the table form, and then we use the star to indicate the accept state. And clearly in the diagram you can see that we have two accept states, which are Q1 and Q2, and so we need to use Q star to indicate Q1 and another star to indicate Q2. That is what we have done in here. And so the arrow is pointing to Q0, which is our accept state. The start state. Exactly. So let's go on. Let's do the mathematical calculation of how the machine accepts or rejects the languages. I mean the strings. And so if you're at Q0 and you receive an input of 0, what do you transition to? You transition to Q1. Why is it so? Because if you're at in the diagram, if you're at Q0 and you read an input of 0, you go to Q1, which is the accept state. That is why we have Q1 here. So Q0 receive an input of 0. Let me just talk about the diagram. Why we have 0 and 1 here. So 0 and 1 here are because the language or the alphabets of this machine are zeros and ones. And so we have 0 and 1 at the top of the state here, and then the state, this is where the diagram we indicate our state, where we have to put the state. And how many state do you have in here? You have 0 not to 4 state, the Q0 to 4 Q4. That's why we have Q0, Q1, Q2, Q3, and the last one as Q4. Right. And so like I said, let me just go back to the calculation. If you're at Q0 and you receive an input of 0, you go to Q1. And if you're at Q1, if you're at Q0 again, you receive an input of 1, where do you go to? If at Q0 receive an input of 1, you go to Q3. And what is Q3? Q3 is a non-accepting state. That is why we haven't indicated any star to it. So Q3, that is what we have in here. And then if we at Q1, which is the accept state, and receive an input of 0, where do you go to? You still remain in your position, because it's like basically like you are at a position where you are not doing anything. You still maintain your position, right? That's how it is. And so if you're at Q1, and receive an input of 1, you transition from Q1 to Q2. That is also an accept state. That's why we have let's not talk about that for the meantime. So Q2, right? Right. And then if you're at Q3 and receive an input of, where is Q3? Q3 and receive an input of 0, you go to Q1. That's why Q3 receive an input of 0, you go to Q1. I think I've just jumped Q2. Right. Q2 receive an input of 0, you stay in Q2. If you're Q2 receive an input of 1, it's still stay in Q2 because it's a self loop. Now let's go to Q3. Q3 receive an input of 1. Sorry, Q3 receive an input of 0, you go to Q1 because the arrow point to Q1. And then if you at Q3 receive an input of 1, you go where? You go to Q0, which is a non-accepting state. Basically, that's what we are doing here. You are mapping out the stages where you can transition from a place to another. And if you can't transition, you maintain your position. That's how it is. And so that's for the transition table for the DFA above. I mean, right now on my screen is beside this. I've split it into two. So this is how we find the transition table. It's short as simple as that. And now let's talk about the minimization. Let's talk about the minimize the DFA diagram. And so there are some steps to note when finding for the minimize, or when solving a minimizing a DFA diagram. First of all, what we need to do is to remove unreachable states. And what are unreachable states? Back to the diagram. If you look carefully here, you can see that some states are reaching to others, but if you look at one particular state, which is the Q4, it is not really reaching to. It is not being reached. I mean, yeah. Right now you can see that Q0 is reaching to Q1. Also, Q3 is reaching to Q0. That is why you also have Q0 reaching to Q3. Now, on Q1, you can see that Q1 is also reaching to Q2, right? And Q2 is reaching by itself. Now, look at Q4. Q4 is not reaching, it's not being reached, but it's reaching to others. That's why we see we can't reach Q4. It's like there's no path that is getting to that destination. That is why we take it away. We take it away from the diagram to minimize some parts, to minimize or to get a close diagram of the DFA. So we say that the Q4 will be discarded. We will delete the Q4 in this diagram. Right. The partition. The partition is all about dividing the diagrams into two: the non-accepting state and the accepting state. And then going back to the diagram, I have to refer you thousands of times to go back and to know what you're talking about. If you clearly see here, you're seeing some diagrams are being doubled, and then you call them as accept states, and some are not doubled, and you call them as non-accept states. That's all that you are talking about. And if you want to find or to reach this state, this is how we do it. We test each state in Q0, Q3, because we are pairing these states because some are accepting states and some are non-accepting states. And Q0 and Q2 are being paired because they are non-accepting states. That's why you pair them against 0 and 1, which are the attributes, the string 0 and 1. Tracking which position each transition lands to. Maybe it lands in or something. And so Q0, let's track this non-accepting state as Q0 and Q3. If you're at Q0 and you receive an input of, if you're at Q0, let me just split the screen into two. If you're at Q0 here, receive an input of 0, where do you go? You go to Q1. That's why you have here 1 here. And what does the ACC mean here? It means accept. And then if you're at Q0 again, you receive an input of 1, where do you go? Q0, receive an input of 1, Q3. And then you can clearly see that it's not doubled. And what does that mean? What does that mean? It means that it is non-accepted or non-accepting state. And that's why you have the Q3 as reaching, or the Q0 reaching to Q3. Now let's go to Q3. Q3, and you receive an input of 0. Where do you go? Q1. What is that? It's an accepting state. If at Q3 you receive an input of 1, where do you go? You go back to Q0, which is what? Non-accepting state. Now let's go to the next part of the partition, and so that we call that as the accepting state. Q1 and Q2 are the accepting state. Why is it accepting state? Like I said, it is doubled by a circle 1, 2. Q1, Q2 are doubled circled here. That's why we call them accepting state. And so if you're at Q1, you receive an input of 0. Where do you go? Q1, you receive an input of 1. 0. It's a self loop, and that's what's that? It's an accepting state. If you're at Q1 and receive an input of 1, you go to Q2. What's that? It's an accepting state. If you're at Q2 and receive an input of 0, Q2 receive an input of 0. Where do you go? Self loop. You maintain your position. If you're at Q2 again, you receive an input of 1. Where do you go? Self loop. You maintain your position. Now that's all that we need to know for now. Let's quickly go on to, so both Q1 and Q2 land in the accepting state, or the accepting group. Q1 and Q2 on both symbols, right? So they are identical behaviors, right? And so Q1 and Q2 also stay merged. No further splitting is possible. Just basically, I mean, you can also have to be. So final partitioning equivalences and classes. Let's just call Q0 and Q3 as part, or as A, and let's call they are non-accepting state, fine, and then Q1 and Q2 as B, accepting state. Now why do you have the minimized diagram as this? Like I said, A and B stand for Q0 and Q3, and B stands for Q1 and Q2. Right. Yeah, that's what we're talking about. And so this is how it works. And so if you are the, you know what this means is that start state, and this is the accept state. If you're at Q1, if you're at A, if you see the input of 1, where do you go? You still maintain your position. And if you're at Q, yeah, if you're at A and you still receive an input of 0, where do you go? B. And then if you're at B and you receive an input of 0 and 1, you still maintain your position. That's what we have here. This is just the same as this, because 0 and 1. What does 0 and 1 means? 0, 1, 0, 1. You maintain your position. You still maintain, and 0. You just move, and then you still 0 and you maintain your position. So basically, this is the derived minimized diagram of the previous DFA, the DFA that we are talking about. And so with this, let's just do the transition table for this diagram, for this deminimized diagram. If you're at if you're at A and you receive an input of 0, where do you go? You go to B. That's why you have B here. And if at A again you receive an input of 1, it's a self loop, so we still maintain your A position. Now the B is the accept state. If you're at B and receive an input of B, if you are B and receive an input of 0, 1, you still maintain your position. 0, 1, BB. Basically, that's all that we are talking about as part of the tax 2. So that's all for now for tax 2.